let r be 1/2. So then it can be shown that negative natural log of 1 minus r is equal to the series 1 to infinity of 1 over n r to the n. So using the fact that they're giving us our value of r, I'm plugging it in. So that way I get that the series n equals 1 to infinity of 1 over n times 1/2 to the n is equal to negative natural log of 1/2. So in part A, it says, find the smallest number m so that the sum sk is less than m for every positive integer k. So what this is asking us to do is to find the upper bound for all of the partial sums. So S1 is going to be smaller than S2, which is going to be smaller than S3, which is going to be smaller than SK, etc. So we're looking for the upper bound for any of these partial sums. Now, if we take a minute to think about this, the series is going to converge to negative natural log of 1/2. And the partial sums converge to negative natural log of 1/2. So every time I take a partial sum that's higher than the last, I'm going to get closer and closer to the negative natural log of 1/2. So the upper bound is going to be what the series converges to. So we're going to say that m is negative natural log of 1/2. Part B says find the third partial sum. So we got to find the sum from n equals 1 to 3 of 1 over n, 1/2 raised to the n. So we need to find all of these terms added up. Here's when n is 1, here's when n is 2, and here is when n is 3. And when we add that all up, we get that it's 0.66 repeating. So now we're going to use this in part C. Part C is telling us, is basically talking about error. So if I wanted to find the actual error, if I look at my full series from 1 to infinity, if I estimate that with just the third partial sum, S3, then there's going to be an error, and the error is going to be whatever is left over, right? Because I stopped at n equals 3. So whatever is left over is going to be the error. So that's going to be from 4 to infinity. So if I know that this is equal to negative natural log of 1/2, and the series from 1 to infinity is the series from 1 to 3 plus the series from n to infinity, then the error is going to be equal to this. So just using a little bit of algebra, I can figure out what the error is by taking negative natural log of 1/2 and subtracting 0.6 repeating. So this is going to be the true error if we use S3 to approximate the series. And that's given here, right? So it says this is the true error right here. But what the question wants us to do is to actually estimate the error using this. It says that the error from 4 to infinity of this, that's our actual error, okay? It's going to be less than this, okay? So this is going to be bigger. And so if we say that n equals 4 to infinity of 1 over n times 1/2 to the n is less than or equal to this geometric series, n equals 4 to infinity of 1/4 times 1/2 to the n, we can estimate this error using our formula for the geometric series. Now, I know if n started at 0, from n equals 0 to infinity, I would get that it converged at 1/4 over 1 minus 1/2. But this is for the full convergence from 0 to infinity. However, this is going from 4 to infinity. So then once we figure out what this is, we're just going to subtract off those first 4 terms of n equals 0, n equals 1, n equals 2, and n equals 3. When we subtract all of that off, then we'll get our estimate for the actual error. Now, when we do that, we're going to get, let's see, I have this written down somewhere. We're going to get 0.03125. When I do all of this arithmetic here, we get 0.03125, which is going to be more than the true error because this is bigger than this. But it's an estimate of the error. And that's what they're asking you to do here. They're saying this is the true error, which is less than this estimate. And all we have to do is figure out what this estimate is. And we can figure out what the estimate of the error is. And because we know that this is bigger than this, when we get our answer, it should be bigger than the actual error. And 0.03125 is definitely bigger than that.